Okay, this is 8th grade lesson 6.1. Our objective today is students will develop an understanding of perfect squares and be able to solve for the square of a number. The standard covered in this lesson is 8EE2. The page numbers out of the hardcover book are pages 230 through 235, and out of the practice journal, pages 116 through 120. Yesterday in our activity, we began working with square roots by understanding that, like, when we have a square, in order to find the sides of each, they have to be the same. Well, square root is the same concept. When we solve for a square root, we are finding what number times itself would give us that answer that's underneath of that square root symbol. So a square root is a number that, when it's multiplied by itself, equals the given number. Every positive number has a positive and a negative square root. A perfect square is a number with integers as its square roots. So in other words, a perfect square is when we get an integer. So we've got integers are going to be whole numbers and their opposites. So 4 times 4 would give us 16. We would also get -4 times -4 would give us 16. So here, a positive square root would be this situation. So we've got the square root of 16 gives us 4, or 4 times 4 is 16. We can also go through and get the same answer if we had -4 times -4. Remember, when we do two negatives, when we multiply, we count those and they make a plus sign. So -4 times -4 would also give us 16. So here we could also have the answer of -4. Okay, so this 4 or -4 would be the solution to the square root of 16. A negative square root, on the other hand, is going to have where you've got a negative sign on the outside of that radical symbol. So we'll discuss that in just a second. You're going to solve whatever's inside or underneath of that radical sign, and then you're going to just apply your negative afterwards. Okay, both square roots, to identify when they are wanting both of the square roots, they will usually do a plus and a minus sign underneath, identifying, please tell us both of them. Or they will do it in wording such as what I have here, where it says find the 2 square roots. So there's not really 2 different numbers. There is, but you're just going to apply a negative sign in front of that same positive number. So let's go over a little bit of vocabulary before we move on here. Our vocabulary that we need to understand is the symbol. I will often call it the square root symbol. It does have a technical name of the radical symbol or the radical sign. So if you ever come across that wording, it's just meaning this symbol, what I call the square root symbol. It's used to represent a square root. The number under the radical sign is called the radicand. So for example, here, 16 would be your radicand. Okay, I will probably still refer to using square root and so forth. So here it says, find the 2 square roots of 49. So in other words, here's visually what they're asking. They're asking us to find both square roots of 49. Okay, see how I kind of introduced it like that. Had I just asked for the square root of 49, you could give me, well, what number times itself would give us 49? That would be 7. So you could identify it as just 7. But if I want to identify both of them, I have to remember that it could be a positive 7 and it could also be a negative 7. The way that is simpler to write that out is to just do your plus and minus sign in front of your 7. So you only have to write it once. I will accept either, but I do want you to kind of practice this for today, so that you're understanding how to actually see that and understand that if you come across that maybe on Iowa Assessment or STAR or something like that, that you're understanding what that's really representing. Okay, so let's go ahead and try another one. They said we're going to do perfect squares right now, ones that are easy for you to do in your head and that you shouldn't have to use your calculator for. Okay, find the 2 square roots of 81. So in other words, they're asking this. This is how it would look if they did this in word or without words. They would be showing you this. Okay, so I want to find the positive number and the negative number. When I multiply them times themselves, that would give me 81. Well, multiplication facts, 9 times 9 equals 81. So it's going to be an answer of 9. And I could have positive 9 or I could have negative 9. And those would both give me a positive answer of 81. So this is my final answer. Okay, let's try one more and then I'm going to have you guys do one on your own. Find the 2 square roots of 25. So visually, this is what they're asking. It's just that they put it into wording. Okay, so the square root of 25, well, 5 times 5 is 25. So 5 would be my answer, and I could either have positive or negative 5. This is my final answer. All right, so I'm going to slide one out here for you to try independently. Go ahead and try this one. Find the 2 square roots of 64. So you can pause your video if you need to and work through this one. Okay, the 2 square roots of 64 are positive and negative 8. Now, this same concept can be applied. They don't have to be perfect squares. For example, if we had the square root of 4.84 and they asked for both of those, we could go through and actually solve that also. We could find the square root of 4.84, which is 2.2, and then we can still do that same answer format for this. It's just I was working those perfect squares with you just because I know that those are multiplication facts that you know. When you get into more advanced problems, can you use a calculator to help you? Sure. But we will also practice some different methods that you can use without going through and using the calculator throughout this chapter. Okay. All right, so here we're going to go ahead and work with sometimes when they give us those fractions and decimals. And I already precursored that in the previous one working with the decimal. It's also, we're going to go through and do the same concept doing fractions. So here, when I'm looking at this, understanding how to read this negative, the square root of 9/16, they are only wanting the negative answer. They're not wanting both of them. If they want both, they will give us the plus and minus symbol on the outside, or they will ask in words. So let's review really quick, which we only did one of these in our activity yesterday, how to solve the square root of 9/16. You can either look at it as the square root of 9/16, or for some of you, it might be easier for you to think of it like this, okay? And think of it as a perfect square over a perfect square versus a fraction, right? So if I were to solve the square root of 9, well, that would be 3 times 3 is 9. And the square root of 16, well, 4 times 4 is 16. So I know that my answer is going to be 3/4. Now I'm just going to go ahead and apply a negative sign on my answer because that's what they asked for here. So this would be my final answer. The negative square root of 9/16 is negative 3/4. Okay, we apply that on the outside. Why would they ever do this? Probably because eventually they're going to be doing where they put a number in front of this and then they're asking you to do that next step and solve. So then I would look at that as 4 minus 3/4 to then continue my orders of operation. Okay, so let's practice a few of those where we're working with the fractions. Okay, so this time they want the positive and the negative. So in our final answer, we're going to have a plus and a minus sign. So think of it like this. What's the square root of 1? Well, square root of 1 is 1. And then the square root of 9/61. And you may use your calculator if you would like to on that. Square root of 9/61, let's see. 9/61 gives me 31. Okay, so I end up with a final answer of the positive and the negative of 1 over 31. Okay, eventually, as you get into more advanced problems, they may do that and ask you to find both answers. So then they might throw a number out here. And so they're going to ask you to find two different answers. So 4 plus 1 and over 31 would give me 4 and 1/31. And then 4 minus 1 and over 31 would give me 3 and 30 over 31. Okay, so that's just something that's a little more advanced right now. We're just going to focus on doing this part of it right here. Okay, eventually they will add that next step to us. Okay, I want you guys to try this one independently. So you've got the positive and negative square root of 4/25. So remember, you can break that down into the square root of 4 over the square root of 25. Go ahead, pause your video and work through this one. you should have gotten a positive and a negative of 2/5. Okay, so that's working with those, those square roots of rational numbers. So now we're going to go ahead and do the same concept, only this time we're going to be working with decimal numbers. Okay, so here the square root of 2.25. Now, if you would like to use your calculator to do this, you may do that. You can go ahead and use your calculator if you have your square root button, just because right now I'm having you practice this concept right now. Okay, so 2.25, the square root of that would be 1.5, so plus and minus 1.5. This would be my final answer. Remembering, if it asks for the positive and the negative, I have to include those in my final answer. Okay, so this time they're asking for the positive and negative of the square root of 4.84. Okay, so I've got the positive and the negative, and now the square root of 4.84 gives me 2.2. This is my final answer. Okay, remembering, understanding how to use that calculator. Okay, if you've got your square root button, it depends on the calculator. Sometimes you push that first and then the digits, and sometimes you do the digits first and then the square root button. You have to remember from yesterday how your calculator works. Okay, I need the negative square root of 1. Okay, remember, anytime you have 1 underneath, 1 times 1 still gives you 1. So your answer here is going to be a 1. And this time they were only asking for the negative of that. So my answer is going to be a negative 1. Okay, remember, eventually they'll be putting a number maybe out in front of this. And they might say 4 minus the square root of 1. You would solve your square root of 1, which is 1. And then you would do 4 minus 1. Okay. So our final answer there was just a negative 1. All right, I want you to try this one. If they don't ask for anything out here, then that means you're going to go ahead and just give your positive answer. Okay, so if they don't ask for anything, or they don't put in words that they want both of them, they leave it blank, then you're going to go ahead and give your positive answer to that. So go ahead, pause your video and work through this one. You should have gotten 3.5 as the square root of 12.25. Okay, so that's working with just square roots, some rational numbers, which are fractions, and then also our decimals. And yes, you can use your calculator to help. Remember, when you're working through the fractions, though, to just remember you're working, for the most part, you'll be working perfect squares there. I know, like on this one that I just pulled out, 961 isn't a perfect number that I have memorized, so I might use my calculator to help with that one. But if I had a smaller number like I had here, I know the square root of a 9. I should know that one. That's a basic multiplication fact, 3 times 3. Okay, so remember, when you're working square roots, you're finding what number times itself is going to give you that number that's underneath the square root symbol. Okay, so evaluating expressions. So the next step is they're going to go ahead and have us work with that, but they're going to give us more information, kind of what I was explaining to you in the previous slide. So evaluating expressions. When evaluating the expressions, you must follow your orders of operation, your PEMDAs, right? So please excuse my dear Aunt Sally. We still have to use in this. So where do roots come into play in that PEMDAs? Because I say nothing about roots in there, right? Well, square roots are the opposite of exponents. So remember, if we had 3 squared, that's an exponent right here. That's the same as the square root of 9. Gives me 3, or 3 squared, right? So roots and exponents are opposites of each other. So they're going to fall on the same level. So when I go to solve these, I'm now going to have to understand that if I have square roots, those are going to be solved whenever I would solve an exponent, okay? I also want to go through to help you understand how to read these, because I know sometimes it's confusing when they start throwing in that square root. What does that mean? Well, when you have a number that's sitting outside of the square root with no symbol right here, that means that you're multiplying. It's the same as when we used to work something like this. Okay, we know that when there's no symbol right there that we're going to multiply. It's the same thing when you have that radical symbol. So, or that radical symbol, you're gonna go ahead and multiply when there's no symbol, okay? So we're gonna go ahead and follow our PEMDAS. So PEMDAS, please, our P is parentheses. I don't see any there. My next is my exponents. Now remember, this is also my roots. So do I have any roots in there? I do right here. So I'm going to go ahead and solve that. And I like to put it in a parenthesis when I solve it so that I don't forget to multiply it, because that's a very common mistake is kids will write down the number, or even adults. They'll write down the number and then they just mix it with that 5. I have to remember that I'm actually going to multiply. So when I find the square root of 36, well, that would be 6, because 6 times 6 is 36. I'm going to put that in a parenthesis, and now I'm going to bring everything else down. Notice how I just brought down the 5, and I brought down the plus 7. Okay, so I'm done with my parentheses. I'm done with my exponents. Now I'm going to do any multiplying or dividing. So remember, these are left to right if I have both of them involved, which I don't. All I have is multiplication here, so I'm going to go ahead and do this part. 5 times 6 is 30. Bring down my plus 7. I'm now down to just my adding and subtracting. So 30 plus 7 gives me 37 for a final answer. Okay, steps. We're working those steps. Some of you are very comfortable with PEMDAS, and some of you need to slow down and take your time. Okay, we're adding roots in there. That's something new. As I've worked with many of you on orders of operation, this is where people tend to make their mistakes, is that multiply, divide. They think they always have to multiply first and then divide. But remember, if you have more than one of those operations, you work left to right. Same thing with adding and subtracting. If you have more than one, when we get into more complex problems, you work left to right, okay? All right, let's go ahead and try another one. Okay, so we've got 12 minus 3, and then the square root of 25. So PEMDAS, parentheses, I don't have any. Exponents, which is the same as roots. And that should be a visual. That square root symbol should be something visual, like, oh my gosh, I have to do that first. Okay, unless there's parentheses involved. So I'm going to go ahead and solve this. So I'm going to bring everything else down. 12 minus 3, and then I put my answer in a parenthesis so I don't forget to multiply it, because that's how I'm used to seeing it. So the square root of 25 is 5. Okay, 5 times 5 is 25. So now I'm going to go ahead and move on. I've done my parentheses. I've done my exponents. I now do any multiplying or dividing. I see multiplication here. So I have 12 minus 3 times 5 is 15. Okay, so now I move on to that adding and subtracting. So all I have is subtraction here. Remember, you guys are going to be working integers. So I have 12 minus 15. Okay, some of you are comfortable with these and some of you aren't. So I have to remember, okay, that's a positive 12 and a negative 15. Those are different symbols. So I'm going to find the difference, which is 3. The larger number of 15 had a negative sign. So my final answer is negative 3. Some of you are comfortable with those and some of you aren't. So maybe try it and then check it on a calculator. That final step. Check that final step on a calculator, okay? But I do want you practicing those integers. Okay, I want you guys to try this one. Okay, so this time you do have a parenthesis. So you're going to go ahead and solve everything that's inside of that parenthesis first, still following the PEMDAS. So go ahead, pause your video, work your way through this one, and then check yourself. Okay, you should have gotten negative 15 for this one, remembering following those orders of operation. This time I had a parenthesis, so because I had more than one thing, that's why I circled it. It's more visual for me. And then I thought of this square root of 49 minus 10, I thought of as like a separate problem, and then pieced it back in with that 5 that was on the outside. Okay. Okay, so that's working with some just basic ones. Now we're going to go a little bit more advanced, and that's where they're going to give us the fractions. Okay, I know that you don't like fractions. We're going to practice these. When I assess you on the final assessment, I will give you ones where maybe you're just simplifying radicals like that. okay? But I won't give you the multi-step problems. I want you to practice them throughout the lesson and as you do your practice work, but I will not assess you on those, okay? So when we go through to do these, we've got 1/4 plus the square root of 18 over 2. So 18 over 2, I could go through and simplify those, but here's the one thing I do want to tell you. If you can see that within this, you can reduce the fraction, you need to do that. We have not practiced the square root of 2. That is not a perfect square. It's going to, if you check it on your calculator, it gives you like 1.4142 da 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 da. You guys haven't worked with anything like that. So anytime you have a fraction, your first step should probably be to check, can I reduce the fraction first? Sometimes you can. So when I look at this, 18 divided by 2, can I do that? Yes, I can get 9. So now this is what I'm looking at, 1/4 plus the square root of 9. Okay, so now if I find the square root of 9, well, that's 3, because I'm following orders of operation. I didn't have parentheses. I simplified my root to a square root of 9, so now I'm going to solve that. That's in this exponent part, which is 3. And then I still have 1/4 out here. Whoops. Okay, so 1/4 plus 3, or 3 plus 1/4, is going to give me 3 and 1/4. Key thing to remember when you do this, if you get a really funky number within those radicans when we're solving fractions, go back and double check yourself. Could I have reduced it? Okay, right now we haven't worked with those, what they are called is irrational numbers. The square root of 2 is irrational. We haven't worked with those. So if you're getting a really long decimal number, that should be your first indicator. Right now, I did something wrong. Okay, oh yeah, maybe I have to go back and reduce. Okay, so let's try this one. So ask yourself first, can you reduce that 28 over 7? Can I reduce that down? Okay, so let's simplify that. Can I reduce this down? Yes, that would give me 4. So now I've got the square root of 4 plus 2.2, or sorry, 2.4. Okay, so my square root of 4 is going to give me 2 plus 2.4 gives me 2 plus 2.4 is 4.4. Okay, now these are going to be very basic. I will probably assess you on something as basic as this, but I promise I won't give the fractions in like a really, really long orders of operation problem. Okay, but I will give you some that are as basic as this, where we're getting some pretty easy numbers to work with. Just to see, are you understanding to reduce that fraction first? Okay, so here's a story problem 1, and we're going to work through this one together. Okay, once again, you should be practicing the concepts that I'm doing on the board. If you're not practicing those and you come across them in your homework, you're going to need to come back and rewatch the video. So it's just easier to practice them. Even though I did the last 2 with you, you should be practicing those. Just watching the video doesn't mean that you understand it. Okay, so the area of the circle is 2,826 square feet. Write and solve an equation to solve for the radius of the circle. Okay, so we're going to use 3.14 for pi. We need to jump back to stuff that we learned back in 6th grade and 7th grade, and that would be, how do we find the area of a circle? Pi r squared sounds like area to me. So area of a circle equals pi times radius squared. So we're going to plug in all of the information that we know. Okay, so do we know the area? Yes, it's right here. So our area is 2,826. I'm going to then put my equal sign. Do we know the pi symbol? Yes, they want us to use 3.14. And then times our radius squared, which I don't know that part. That's what they want us to find. So now if I want to get that r squared by itself, right? Because remember, this is now going back to algebra, solving for a letter, okay? So I want to get that r squared for now by itself. So how am I going to get rid of that 3.14? I'm going to divide it. So I'm going to divide this side by 3.14. So that's gone. Now I'm left with r squared over here. But whatever I do to one side, I have to balance the equation and do to the other side. So over here, I have to do 3.14 divided by that. Okay, so we're going to punch in on our calculator. 2,826 divided by 3.14. And when I do that, I just got 900. So I need to now finish this out. This is where lots of times people will make a mistake and they'll say, well, the radius is 900. But remember, it was the radius squared. What number times itself gives us 900? So remember, squared is the opposite of square root. So to find my final answer, I want to find the square root. Because really to do this, I'm square rooting to get rid of that squared. So then I'm going to square root on the other side. So the square root of 900 is 30. So I just found out that r, the radius, equals 30. And I could go back in and plug that into my original equation and put 30 here. So then I would do 3.14 times 30 squared, okay, which would give me 900. And if I punch in 900 times 3.14, it's going to give me my 2,826 on my calculator. So this is my final answer. Okay, so I want you guys to go ahead. I'm going to give you one of these. I want you to go ahead and try it out. So right now it's basic substitution. I'm going to give you that equation. I'll rewrite the equation, but you're going to have to understand that. That's something that you have previously learned. So this time it says the area of the crop circle is 45,216 square feet. What is the radius of the crop circle? So to find your area, it's area equals pi r squared. So you're going to substitute in this where area is, this where your pi is, and then solve to get r by itself. Remember, you want to get it to just be r, not r squared. So you're going to have to do that square root in your final step. So go ahead, pause your video and work through this one. You should have gotten r equals 120, and then our label would have been feet. Okay, pretty complex. They're just giving you higher end. On this one, I won't give you something like that on your assessment, but it may be something that I have you practice on homework. Not to say that you're not going to come across those things on Iowa assessment or STAR. So I want you to practice them. I'm going to focus more in class on the basic square roots and understanding how to simplify those. So remember, as you're working through square roots, you're finding what number times itself would give you that number under the radical symbol or the radical symbol. We will be going through and actually then be working with some orders of operation. So remembering that when you do PEMDAS, that your E is where your square roots would fall into place, okay? So good luck with this one and just keep plugging away. It's a new concept. Yes, you can use your calculators to help you out, but you need to just continue to practice.